All right, number 46 has a lot of parts to it. So let's see how many parts we can get done in a few moments. So we want to solve for x here. It's 46 part A. 4 to the x power equals 1024. So do you know your powers of 4 that give you 1024? Well, let's just see if we can figure that out. 4 to the third, 4 to the fourth, 4 to the fifth. It's to the fifth power. 4 to the fifth power equals 1024. Now, if you want, so that means that x equals 5. Okay. Now, algebraically, what's going on here is I could rewrite 1024 as 4 to the fifth power. And now, since I have the same bases, I can say that x equals 5. All right. So this is kind of just, if I knew what 4 to the fifth was, I could just say x equals 5. Here, if I can rewrite this to the same base, then the powers must be the same. Or you could take a logarithm. So if I took a logarithm, if I converted this to a logarithm, it'd be log base 4 of 1024 equals x. It's always this. This is your base, because it's log base 4. This to this power equals this. Little base to that power equals that. That's how you rewrite those. Okay. Other people like to look at it. Oh, by the way, log base 4 of 1020. How do you plug that in? Well, I don't have a log button on this calculator, so I have to use the change of base formula. That means I take log of this number. I hit the log button of 1024, and then I divide that by log of 4, because the log button on this calculator is just plain old log base 10. This is the change of base formula, and that gives me my answer, x equals 5. Okay. To get this into the logarithmic form, some people like to say, well, I'm going to take log of both sides. I'm going to take log base 4 of both sides. And when I take log base 4 of 4, it cancels basically, and I'm left with x. And that's one way of rewriting these. Okay, so all right, so let's try part B. 2 to the 2x equals 8. Well, 2 to the third power? 2 times 2 is 4 times 2 is 8. So if I could rewrite that other guy as 2 to the third power, 2 times 2 times 2 is 8. So now I have the same bases, I can set the powers equal. And then divide by 2, your x is 3/2, 1.5. Okay, now, a second ago, if I rewrote this as a logarithm, I'm going to take a logarithm of the left side, take a logarithm of the right side. I'm going to do logarithm of both sides. And if it's a base and this base is the same, it essentially cancels. So what is log base 2 of 8? Well, log base 2 of 8 would be log 8 divided by log 2 if you have to use your whole calculator here. It's 3. So that is 3. All right, it's 2 to what power gives you 8? Well, 3 does. Now, divide both sides by 2, x equals 3/2. There's lots of different ways of doing these. That's probably the two ways that I prefer to do those questions. All right, here's 5, x minus 2 equals 29. Now, I know that I don't know what power on 5 gives me 29. I know 5 squared gives me 25, but I want 29. So I have to do these questions now like this. I'm using the properties because I can't rewrite them. I just don't know what that number is right there. So I'm going to take log base 5 of both sides. Or basically, I'm changing it from a logarithmic to an exponential, from an exponential to a logarithmic equation. Now this is not going to be a nice number. What power on 5 gives me 29? 2 point something, but it's going to be 2 point blah 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 blah. So I'm going to leave it this log base 5 at 29, and then I'm going to add 2 to both sides. My x is equal to log base 5 of 29 plus 2. Now if I want to find out what that value actually is, remember I just have to use my change of base formula. Log 25 divided by log 5. Not 25. Why am I writing 25? 29. Good Lord. 29. Log 29 divided by log 5. Sorry for the confusion. 2.0922. And then we're going to add 2 to that, plus 2. So 4.0922. It just says solve for x on the question. So if it wants to, you probably want to round. This is the exact answer. So we're calling the exact answer. The decimal approximation would be 4.0922. I'll take it out to 5 spots. Right, we'll round it to that spot right there. It didn't ask, but I'm going to. I just rounded it anyways. Try it one more time. Part D. I think 4 to the 3rd or 4 to the 4th is 256. I think 4 to the 4th. Let's see. 4 to the 4th is 256. So since I have the same bases, I can set the powers equal. Let's add 3 and then divide by 5. So x is equal to 7/5. Okay. Now let's do part E. Let's do part E, and then we'll stop this video and start with the other half. So here we've got 3. This is part E. 3 to the 2x plus 1 equals 7. I don't know the power on 3 that would give me 7. So I'm going to rewrite it as a logarithm. I'll take the log both 3 of both sides. Essentially all I'm doing is just rewriting it as a logarithmic equation. Now this is a number, and if I plug that in my calculator to figure out what that number is, it'll be some decimal, like previously we got some decimals. So let's just solve this by solve for x now by subtracting 1. Now I'm not going to. This is the number by itself. You don't say 7 minus 1 or anything like that. This is in parentheses. You don't screw with it. And then divide by 2. You divide all that by 2. So x is equal to log base 3 of 7 minus 1 all over 2. If I want to type that in my calculator, I got to figure out what this is. I'm going to subtract 1 from that, and I'm going to divide that number by 2. So it's log of 7 divided by log 3. Okay, that's how I figure out that number is. It's 1.7724 minus the 1, 0.77, and then we divide that by 2. So my answer would be 0.38562, approximately 0.38562. This is the exact answer, which is fine. This is the approximate answer. Okay. Let's split this up. I'll do F through J in the next video.